Yeah, hi everyone. What we're going to do today, as Felix said, is what I wanted to do was look a bit at containers, containerization, Docker and Kubernetes. I've been doing this for about 5 years now, and just doing container work, and I've been in security for a while. So the idea here is first to talk a bit about how they work, because I think whenever I'm hacking something, I like to understand how it works, how it's put together, because that's going to help me in understanding where things might go wrong. If anyone has got questions as we go, feel free to put them in the chat. I'll put that window up there. Also, obviously, I have a Scottish accent, as you might have told. If something's unclear, just ask me to repeat it. This would not be the first time. I am aware that Scottish people can talk quite quickly. So very quickly, get past this. I think this has been covered. My background is penetration testing, information and IT security for a couple of decades now. These days, I work in cloud native, containers, that kind of thing. CIS Benchmark author. I'm also a member of the only unofficial special interest group for Kubernetes to have presented at KubeCon US and EU, which is SigHonk. And if you get into container hacking, you might see this kind of goose meme everywhere where it's honking. And it's to do with a thing called the Untitled Goose Game, where a goose went around a village and caused mischief. So the idea is with hacking, we're sometimes causing mischief. So we call ourselves SigHonk. To get an idea of, this is where I live. This is what it looks like when it's not raining, which looks very nice, very pretty, and you can go up in the hills. Unfortunately, it rains quite a lot here. But it looks very pretty when it isn't. So I'm going to get started and get on with the talk. The first thing to talk about with containers and containerization is that this isn't new. Containers aren't something that's just come up, although they are a lot more used now. It actually started in 1979, long time ago, when the chroot system call got introduced to Unix. Then around 2000, we got a lot of container style technologies, BSD jails, Linux vServer, large zones. But it was really in 2013 when it started getting super popular. And I think that was Docker. Docker was the kind of catalyst for that. It made everyone kind of sit up and pay attention. A lot of developers use it. And now, I mean, you'll all know, if you go to almost any open source repository and you look at the installation instructions, they're probably going to have a Docker file in there. It's pretty much, everywhere. And this kind of shows an idea. This is Stack Overflow. They do a survey every year asking developers what they use, what programming languages, what tools, all that kind of thing. Docker is right behind Git. So after everyone uses Git, but apart from Git, Docker is the most used tool for professional developers. And we can see Kubernetes are getting in there as well. So Kubernetes, which we'll talk a bit about what that is and how it works, that's getting a lot more popular as time goes on as well. So there is a problem when getting into container security and when getting into container hacking, and that is all the terminology. Like anything new in IT, there is a huge number of buzzwords, terms that get bandied around, and that can make it hard to understand what's going on. If you don't understand the details of what these things are, if you don't know what a cluster role binding is and how it works, it's hard to understand. Think about, like, how could I hack into this? How might it go wrong? Because you don't understand what it is. So what I wanted to do now was actually talk a bit about what containers really are, how they actually work, and then that will give us an idea of what we can do to attack them or defend, depending on which side of the fence you sit. So this is kind of an idea of what a container is in reality. And we're talking about Linux containers here. You do get Windows containers as well, but they're a fairly different idea. So we're going to focus on Linux containers, which is where most people will spend their time. Essentially, a Linux container is a process. It's a Linux process, just like any other process on the host, no different. And I'll demonstrate that in just a second. And what Docker does and the other containerization tools do is they basically make use of a set of existing Linux facilities to isolate each process from the underlying host and from each other, so that one container can't easily interfere with another container. The way it does this is, first up, we have namespaces. So Linux namespaces are a very useful thing for isolating a process's view of the host. What do I mean? Things like, for example, the mount namespace. That says this process can only see certain directories. The network namespace says this process can't see all of the network adapters that are on the host. It can only see maybe one specific adapter. So the idea is namespaces are a good way of isolating a process's view of the host, and containers basically use that. We then have capabilities. Capabilities are a really interesting part of Linux security. What they basically do is break down root's rights. So in the old school of Linux, you either were root and you had all the access to a system, or you weren't root and you had very limited access. That's not a very good security model. It's not very flexible. So Linux kernel team came up with capabilities. And capabilities allow you to have a little bit of what root has without giving you everything. And what we do in container land is we actually give every container some capabilities by default. Even if it's not running as root, it'll actually be given some capabilities. And that's just part of what Docker did when they were coming up with like a kind of sandbox of reasonable isolation. There's actually been, if we get time, I might talk about it, but there was a really interesting vulnerability around capabilities and how you could exploit them that came out just last week, Linux kernel, CVE. Maybe mention that if we get a chance. Then what containers do is, they then use C groups. So C groups are designed to restrict how much resources a process can use on a Linux machine. So if I've got like 10 containers, I don't want one of them to use all of the CPU or memory or PID handlers on a machine. You need to use C groups to restrict that. Interestingly, by default, Docker doesn't actually set that. It doesn't actually set any C groups up. So if you ever want to DOS a host that's running containers, just use a standard Linux fork bomb. And a fork bomb will essentially use all the process handles on the machine and crash the host. It will work out of the box on Docker. We then have a couple of extra layers. We have AppArmor and SE Linux. AppArmor and SE Linux, if you've not come across them, are just mandatory access control systems. They essentially allow you to add another layer of security to a process to try and restrict what it can do. So if other things fail, the idea is that they will catch that and still block the access. And then lastly, Docker has a seccomp filter. And a seccomp filters are used to block individual Linux kernel syscalls. And what Docker did was they went through all of the syscalls in Linux, and they basically said, these are the ones we think are dangerous, and we will block those syscalls by default. Interestingly, despite that being on in some container environments, it isn't on in a lot of the time when you run under Kubernetes, because the Kubernetes project decided to disable it. And that has been the subject of some CVEs, because Kubernetes essentially removes that layer of isolation by default. So there's scope there. Even if your exploit isn't working on Docker, sometimes it will work in Kubernetes because of that change. So that's the idea essentially of what Docker does. The reason developers, I think, really like Docker is you don't need to know about any of that at all to get Docker working. You can get an isolated process running on a machine without knowing the first thing about any of those just by using Docker. So we're going to demonstrate a little bit, just to kind of show you what I mean when I say that containers are just processes. So I've got a machine here, and this machine is running Docker, and I've got rights to run Docker commands. So what I'm going to do, just as a startup, is I'm going to look to see if there are any Nginx processes on this machine at the moment. And sometimes I copy paste stuff and it goes very odd when I do this, but let me just get one that will work. Oh, that'll work. Okay, so we've got this showing essentially at the moment we have no Nginx processes running on this machine. So as far as the machine is concerned, there's nothing there. We're now going to do Docker run. So this is just running a new Docker container. And we're going to give it a name. We're going to call it web server. And we're going to use the Nginx image. So Docker goes away and it runs an instance of Nginx. If we look at from a Docker perspective, we can see that Docker now says, yep, I've got an instance of Nginx and it's called web server. But Linux itself, the host, it doesn't know what containers are. It has no idea what a container is. So what does it think's going on? Well, if we run our ps command again, what we can see is now, as far as the host is concerned, we now have a load of Nginx processes. So we've got the initial Nginx process that's been launched, and then we have its forked processes, its worker processes. So as far as when I say containers are just processes, I literally mean containers are just processes. And this kind of lets us interact with containers in some fun ways as well. So what we can do is, just to demonstrate that, if I do Docker exec, so Docker exec just executes a command inside a container. So we're going to execute something inside our container, and we're going to execute touch, and we're just going to create a new file. So that has created a file called my new file in the root of the container file system. And the question is, can I actually see that file from the host's perspective without going anywhere near Docker, without running a Docker command? And the answer is yes. Because if I do sudo ls and we do proc and then the PID of the master process and then root, what you'll see here, so the proc file system, as I'm sure some of you will know, is a virtual file system in Linux which contains information about the host and every process running on the host. What we can do if we want to look inside a Docker container without actually running Docker commands is we can just look inside the proc file system for this process, which is our contained nginx process, and then root just says, show me the root file system. And we can see here, this is what the nginx process thinks the root file system looks like. We can see all the nginx files that come from the image, and then we can see my new file. So that's an important point when you're thinking about containers. Containers are just processes. If you have root rights to a host, you can look inside any container, you can interfere with containers, you can modify how they run. You can create things that work like containers without touching Docker. You can manually set up namespaces, you can manually remove capabilities. So it's possible to do all these kind of container things without using Docker. But what Docker does, and also the kind of reason that it's so popular, is you don't need to know all those details to make it work. So that's containers being processes. The question then, though, is when I ran those commands, when I did that, I used an image, right? I used a container image, and a container image which I got from Docker Hub, which was the nginx container image. So what is it? What is a container image? We're trying to understand these things and how they work, right? So what is a container image? A container image, of which there are, actually that screenshot's a bit out of date. There's about 8-point-something million on Docker Hub now. They're literally just tarballs. So they're just Linux tarballs with JSON metadata. So when you create a container image, all you're actually doing is you're generating tarballs and like putting it together and then sending it to Docker Hub or some other registry to be stored. And we can kind of demonstrate that as well. So let's have a little look. So I'm going to create a top level directory here because otherwise this is going to make a mess on this machine. So I've just created a directory, go into it, call it nginx. Then what I'm going to do, and let's hope my copy pasting is working now. Let's see if it's going to be happy today. I'm going to save the nginx image. So this command just says, get the Docker image nginx latest, and then create a tarball called nginx save out of that image. And you can do this with any Docker image. If you want to inspect or like poke around in a Docker image, you want like maybe if someone's put secrets in there or made some kind of mistake, you can just save them into tarballs and then look at the tarballs. So that will happily go and create our tar file. Yep, it's done that. And then what we can do is we can extract it and have a little look. And what we're doing here, we're just untarring it. And this actually is a handy tar switch. I didn't know until recently. You can make it create a top level directory so it doesn't make a mess of whatever you're in. And so we now have a directory called nginx save. So in this is essentially what is in a Docker image. And what you can see is it's basically a couple of JSON files and a series of directories with SHA-256 hashes. That essentially is the hash of the contents. So the idea is they create a directory with the hash of the contents, they then put the files in. And each one of these is one layer in the Docker file. If you've ever looked at a Docker file, you'll see they're made up of like a number of statements. Each statement in a Docker file becomes a layer, and then the layer gets turned into a tarball. But basically that's all it is. And if I do helps if I had it installed, eh? That's going to work quickly. Thank goodness for good internet. We can actually see what that looks like. So each layer has a JSON file which describes the layer, and then it has another tarball with the files that are part of that layer. So basically, these are just like sets of nested tar archives, and that's what a Docker image is. The one thing I would say is that's not great if you want to like look at the contents of the image. It's a bit messy. Yes, you can go in and you can extract each layer from inside its tarball, but it's a bit of a kind of time-consuming process. So there is a better way. what we can do here is we can export our running container. So this is just a different Docker command that basically turns any running container into a tarball. And then once we've done that, we can then extract that. And the difference between the save command and the export command is when we look inside the directory for our tarball for our export command, we can see all the files. There's no tarball. It just basically flattens the file system. And we can actually see here, there is that new file, the file I created earlier on, because essentially it's taken the entire container and all the contents of it, turned it into a tarball. So you can do anything you want there. You can kind of like mess around with the contents and retar it up or whatever else. But that's just to say, again, hidden behind all the container buzzwords and the container terminology, this is just Linux. Everything Docker does is Linux. It's tarballs, it is processes, and it's Linux features for isolation. And when we know that, we can think, well, how would I, play with that or mess with it? So that's that. So the next question in our exploration of what is Docker is, well, we've said that containers are processes, and we have said that images are tarballs. Where does Docker fit in? What's it doing? How does it work? How is it kind of like making this all come together? And the way Docker works at a basic level is a bit like this. There's a CLI, a command line program. The command line program talks to Docker engine. Now, usually it talks over a Linux socket file, which is just a way of exposing a service locally without having to listen on the network. You can make Docker engine listen on the network, and it's actually a great attack point. If you see a Docker engine on the network, it tends to be pretty easy to compromise the host, and I'll show you kind of how that would work. But basically, Docker client talks to the Docker engine over a REST API. So it's just a standard HTTP REST API. The Docker engine then talks to the Docker registry. That's where it gets its images from. That could be Docker Hub, or it could be another registry. This is also an HTTP REST API. So these are basically just all HTTP stuff. You can get to these things with curl or any other tool that understands HTTP. And then Docker engine, once it's got its images from the registry, it then just launches processes, which are containers. That's basically what Docker does. It just sets up the sandbox and sets up the namespaces and the capabilities and everything else, and then launches a process on the host. And we can demo that as well, in the spirit of keeping kind of showing what we're doing rather than just telling you what's going on. So to demonstrate what's going on with Docker, I'm going to use SOCAT. SOCAT, if you haven't come across it, is a really cool tool for intersecting traffic and like setting up listeners and stuff. And what I'm going to do here is I'm going to use SOCAT to create a new listener, a new socket file on this machine, and I'm going to connect it to the Docker socket. This file here, var run docker sock, is the Docker socket. From a security standpoint, if you ever get access to the Docker socket on a machine, you can generally run Docker commands, which will give you root access to the host. So it's an interesting one to look for in terms of file permissions. If you ever get permissions that give you access to Docker sock, that's pretty good news from a hacking standpoint. But here, what we're going to do is we're going to get Docker sock and connect it to a temporary socket. So when I do that, this will just hang waiting for me to do something. And then in another window, what I'll do is I'll just run any Docker command. I'll use sudo actually, because our new socket doesn't have permissions. And what we'll do is we'll say sudo docker, and then we're going to connect to our new socket. So you can tell Docker to connect to a different socket if you want to. I'm going to tell it to connect to my new temporary socket, and I'm going to say list the images, fairly basic Docker command. And so what we see here is it just lists the images. But what was going on in the background? What did Docker actually do? We said that we've got this CLI, it talks to the engine over HTTP. What was going on? And you can see that in our SOCAT window. And what we can see here is it's literally just REST commands, right? First off, it sends a little ping to make sure it's working. It's got its own user agent, which is a Docker client user agent. And it gets a response back saying, yep, that's fine. So it knows, okay, I can ask for this image list that I've been told to ask for. There's the API endpoint. So that's the version of the API. It images JSON, and then it comes back and gives you basically a list of JSON images, which is then parsed by the CLI and turned into the output we just saw. So that's literally all Docker is. So if you can send curl commands to the Docker engine like that, you can essentially get rid of the Docker CLI, and you can issue any Docker command that way. I actually find this technique here really useful using SOCAT. If you want to try and like work out exactly what API path to talk to, you can use SOCAT, and then it'll happily spit this out, and then you don't have to work out, go and look through the documentation. You can just get it from there. But that's Docker, right? So from a security standpoint, what does this mean? What do we need to worry about? Or if we're hacking it, what does this mean in terms of if we get access to Docker? How easy is it going to be for us to root the box? The answer is very, very easy. Docker has a flexible security model. This is by design. The people who created Docker created it as a developer tool, and their opinion on security is that if you have rights to run Docker commands, you can essentially remove all those isolation layers. So you can remove namespaces, you can add capabilities, you can remove seccomp filters, or you can add them if you want to make it more secure, but it's flexible. Generally, users with Docker access should be considered root on the host. The one exception to that, which you don't see very often, is it is possible to run Docker without root at all. You can run rootless Docker, so it runs as an ordinary user. And then obviously, if you compromise Docker, you'll just get that user's rights. You won't get host level root. But regardless, it is generally root on the host. And we can demonstrate that it's root on the host by running what is called the most pointless Docker command ever. This came from a blog post someone did back in 2015, and I'll walk you through exactly what this does. But this is my favorite Docker command because it's really, really handy for like proving that you can get root. So what we'll do is I'm going to copy paste this one because if I type it, I will make mistakes. This command essentially, at the moment, you'll see I am the Rory user on a host called Goyle. We're going to do Docker. We're going to run. This switch here is give me a terminal, give me a TTY inside the container. We're going to use this switch here, which is -- privileged, and this means remove all the security. If you ever get to run Docker commands and you can add that switch, you're going to remove all the isolation, all the security layers. We're then going to use these three parameters, and these all mean don't use a namespace, right? Don't give me access only to a namespaced resource. Give me the host's resource. So give me the host's network, the host's process list, the host IPC. We're then going to mount a volume inside our container. So we're going to mount the host's root file system inside a directory called /host. We're going to run an image called busybox. And then we're going to execute the command chroot host. So before we run it, we are Rory. When I run it, I am root. You're full root on the host. You can do anything you want. You can go and delete files, add files, change etc shadow, find a flag if someone's left a flag lying around because it's a CTF. But that's how easy it is, and that's an important thing to know about Docker in terms of hacking. If you get access to the Docker socket, or you get access to Docker over a network, you can basically run this command or something similar, and you get to be root. It's that easy. And that's by design, right? That's not really, it is useful to know, but that's how they designed it. So that was Docker, right? And that was a relatively fast spin through Docker. The important takeaway for Docker is that Docker is a one user tool, right? It says one host tool. It's not designed to run on many systems. So if we are attacking bigger sets of hosts, they're probably not running just Docker. They probably need to run something that sits on top of Docker and manages it all. And what they're going to use for that is they're going to use a thing called Kubernetes. There are lots and lots of different types of Kubernetes. There's about 130 different types, but they all work roughly the same way. And it's a bit like this. You have a set of worker nodes. So these are virtual machines or physical servers. On each virtual machine, you have a container engine. And a container engine is probably Docker. Might not be Docker, but in a lot of cases, it will be Docker. Docker talks to a Kubernetes component called a kubelet. A kubelet is a REST API, which sits on the worker node and talks to the API server and to the container engine. So if you say to the API server, launch a new website, it will tell the kubelet, which will tell Docker. The API server sits on the control plane nodes, and it's the core of the cluster. It's another REST HTTP API, and access to that is pretty much game over for the whole cluster because it can manage everything. And then there's a key value store database, which is etcd, usually in almost every cluster. And that, again, has a lot of secrets and various other good information. So if you see that one on the network, it's quite useful. all of these three components have network APIs by default. They're all listening on the network, unlike Docker, which by default doesn't. So they're good attack targets if you see them. And we can talk about how you can compromise those as well. But that's basically Kubernetes. It gets more complicated than that, but that's fundamentally what we're talking. A set of number of REST APIs, basically managing sets of containers. So when earlier on, I said Docker is command execution as a service by design. That's what it's meant to do. It launches processes, right? We showed it launches processes. So Kubernetes is 100 hosts, 1,000 hosts, all running Docker. So Kubernetes is distributed remote command execution as a service by design. That's what it's meant to do. Now, from an attacker standpoint, that's great, right? This thing is literally meant to do command execution. So the same challenge from a security standpoint applies. Is, can we hack this stuff? Can we actually, can we use this? And the answer is yeah, it's pretty easy. And let's demonstrate how. So I've got a little Kubernetes cluster here. And at the moment, I don't have anything running on it. If I do create myself, should be right. There we go. I create that, and that is a little. Whilst that's creating, I'll show you what I just did. This is a simple Kubernetes manifest. They're all written in a thing called YAML, which could stand for yet another markup language, although I think it's got different meanings. And YAML basically describes every resource in a cluster. But if you look at it, it's not too hard to understand. Basically, we are creating a pod, which in this case is just one container. For the pod, in this pod, we're going to say, give me all those host resources. So just like with Docker, we said -- net equals host, we can say host network true. We can also say, give me a privileged container. So do the exact same thing we did before, where we got privileged container. And by default, this will work on any Kubernetes cluster. So if they haven't restricted rights and you have the right to create pods, you can always do this. So if you're ever doing attacking a Kubernetes cluster, a manifest like this is pretty useful because you can use it to get root on the host nodes. And I'll show you what I mean. What I'm going to do is this uses kubectl, which is just a client binary, and it works a lot like Docker. So kubectl exec is like Docker exec, and we're going to use -it because we're going to get a shell inside this pod, and then we're going to execute the command chroot host. So before I execute this command, I am the root user on a host called sapling. Once I execute it, I'm the root user on the cluster control plane node. I'm properly root user, so I've got full access. Now this is by design. If you think about what we said about Docker and Kubernetes, they're designed to execute commands, and they're not that locked down out of the box. Hopefully production clusters, like real world clusters, you shouldn't be able to do this on, but out of the box, this would work. From a hacking standpoint, if you are, once you get onto a cluster control plane node, the things you want to target, my personal favorites is this directory here. It can be in different locations, depending on what type of Kubernetes you're using. But in most, it's in this place here. And in here, you will find all the certificate authority files used by the cluster. The most important one is this one here, which is the certificate authority key file. If you've got that and the certificate file, those two ones there, you can create new user accounts. So you can basically create any user, and you can create users that don't expire for like a couple of years. So it's pretty useful if you can get access to those. And that's generally in the PKI directory. So this is kind of like, this is how Kubernetes is set up, right? Essentially, it's these REST APIs, but you can execute commands that run Docker. That's what it does. How are we doing for time? Make sure I don't run too long. Okay, got a bit of time left. Good. So that's how Kubernetes essentially works. Talking about internet exposed stuff. So if you're looking on the internet, you're doing perhaps bug bounty stuff. What are you looking for? If you're looking for Kubernetes services, there's actually a lot of these online. The API server, which typically lists on like 443 or 6443, There's about 880,000 of those online last time I checked. So there's plenty of this stuff doing the rounds. And if you're doing bug bounty work, it's a question of tying it up to targets. Interestingly, with Kubernetes, a lot of clusters will tell you what version they're running without authentication, which is again handy if you're trying to work out what to do in terms of targeting. There's an endpoint called /version, which basically tells you what version is running. And of the ones I can find on the internet, there's 110,000 returning a version. So about 1 in 8 return a version of the clusters that are visible. Running a visibly unsupported version. So Kubernetes has quite a short support lifecycle. As a result, a lot of people are not maintaining their clusters well. There are 24,000, last I checked, clusters running unsupported versions of Kubernetes. Many of those are in cloud providers. So a lot of EKS clusters inside Amazon are not running supported versions. So they're kind of, there haven't been a huge number of CVEs in the API server, but if there is an API server CVE, there's going to be some people having a very bad day. There's also kubelets. So that was that API I told you about, the kubelet, which runs on every worker node and tells Docker what to do. There's about 100,000 of those online that I could find. And that's interesting because the kubelet should never be online, right? There's no reason to do that. The API server, there's some justification for. You might want to interface it with like a SaaS monitoring service, so you need to have it on the internet. The kubelet, there's no reason why it should be on the internet. Really, there's no reason for it to talk to any host other than the API server, but there are. And there's about 5,000 etcds as well. I don't do bug bounty stuff myself, so I haven't gone probing into like exactly whether these things have got their security set up correctly, but there's a lot of potential targets for sure. In terms of finding stuff on the internet, the ports you're looking for, Docker is port 2375. If you see port 2375, that's typically unauthenticated, and you just basically point the Docker command line at that port, tell it what port to connect to, and you can execute commands. Kubernetes, there's a number of different ports. The API server is 443 or 6443, etcd is 2379, and the kubelet is 10250. So those are the ports typically that one can run. Those two are pretty static. They're almost always the case. Interestingly, and I find this kind of interesting that they do this, some of you will probably have used Census, which is a Shodan-like service if you haven't used it. They actually have a search for clusters that do not require authentication and will at the very least list out their resources without authentication, so badly misconfigured clusters. I think I checked yesterday and there was let me see if this comes up. What are we getting? Are they having a slow day today? Last time I checked, there were about 600 clusters that were visible. Now, a lot of those will be honeypots, I'm sure, but there were about 600 clusters. But it looks like Census is having, shame, it's usually quite a fast service. Oh, here we go. What have we got? 627. So there are 627 hosts on the internet which have Kubernetes installed. It's always quite easy to find Kubernetes online. And they're returning information without authentication, so badly misconfigured. A decent number, I'm sure, will be honeypots, but probably some that aren't. Binary Edge has got similar. Binary Edge has a query called Kubernetes auth required false, so they also index that information. There's a couple of interesting things about Kubernetes security that they surprised me anyway when I first got into it, and I think can surprise companies because they aren't very logical. When you get Kubernetes and you use it, none of the authentication mechanisms it provides out of the box are useful for production. The important one is that they have client certificate support. So you think client certificate authentication sounds okay, but the client certificates do not support revocation. So if you lose a certificate, or if someone leaves a company, or they lose their laptop and they've got a client certificate present, that's quite bad, especially if you put your API server on the internet, because you can't revoke the credential. The only way to get rid of it essentially is to change the keys for the entire certificate authority, which is a pretty major operation that's going to cause an downtime. Kubernetes does not have a user database, which is a bit weird. It relies on the external authentication services that it has. So if you go looking for users in a Kubernetes system, it has no canonical list of them. There is, however, a hard-coded cluster admin group called System Masters. So if you ever see a credential with System Masters access, it must have cluster admin. It's not possible to revoke that access. Even if you delete every rule in the authorization system from the cluster, a credential with System Masters will still have cluster admin rights. And the support lifecycle surprises, I think, a lot of larger companies. It's supported for about 9 to 12 months. Some commercial vendors may go as high as 18 months, but not much more than that. And that's why we're seeing a lot of unsupported Kubernetes around. In terms of tooling, things you can use if you're poking around in containers, here's some of my favorites. These tools are useful for assessing from inside a container. So you can run these tools inside a container and it will tell you things like, what capabilities do you have? What syscalls have been filtered? So they're handy if you're assessing, you've landed in a container and you're assessing how can I break out here? This one here is newer KDigger, and it's doing quite well. It's getting quite well developed. It's focused on Kubernetes. So if you land in a Kubernetes container, that's a good one. Am I contained is more general container. And then there's KubeHunter, which is one of Aqua's open source tools, which is like a pen testing automation tool. So it'll do things like probe the kubelet port, and it'll probe etcd, and it'll probe the API server, and it'll try and find misconfigurations for you. In terms of books, you want to read more on container security and other materials as well. There's a couple of good resources which might be of use. There's a container security book. You can get this one by going to our website and giving them any email address. You give it your email address or someone else's, and that's an O'Reilly book. It's a good place to start. Has a lot of good container security information. There's also a more recent book. This came out just the tail end of last year called Hacking Kubernetes. And that one, unfortunately, I can't find a free version at the moment, but that one is a good book. A lot of good information in there, a lot of kind of more detail on the kind of things I've been talking about and other topics as well. In terms of if you want to try playing with Kubernetes, because it is quite complicated to get started with, and you want a test environment that you can hack into, there's a couple of good options. Kubernetes Goat from Madhu. There's the Kubernetes Simulator, which has a kind of simulated environment that uses AWS, so you might need to watch for credits. And then this is what I've done. This is a Kube Security Lab. What this does is sets up vulnerable clusters, so you can try out attacking, different techniques, and it works purely locally, like on a local machine. You don't need any network dependencies, which is quite nice if you just want to set up and play with it. Training, if you want free training resources, Madhu has very kindly put his entire course online for free, which is very generous of him. And so this is a good resource. You can go through this course, you can work through all the labs, lots of good info there. And also I've got a little site down here, container security site, where I put other information, things like checklists for how to break out of various situations, CVE lists, so there's what all the CVEs in Kubernetes and Docker are, that kind of thing. So 41, almost exactly on time. But I had a couple minutes for questions. I don't know if anyone has any questions or if that was all okay. I shall have a sip of water. Yeah. Okay, questions from people. Lucas asks, what are the alternative authentication mechanisms? So like I said, Kubernetes, you can't use it's shipped ones, you have to use an external. If you're in the cloud, so if you're in AWS, Azure, or Google, use their IAM. They all have an IAM solution, use that. Their clusters, like their managed clusters, work well with that. Outside of that, you need to use Active Directory or your LDAP store and combine that with an OIDC, OpenID Connect software that connects the two, connects your LDAP to your clusters. That would typically be products like Dex, Keycloak, and OpenUnison. So there's different options, but basically it's moderately complicated. But if you're using Kubernetes in production, you do have to do that because you can't use the internal ones. Terry wants to know what my favorite whiskey distillery is. I'm going to say Oban because I'm from Argyll in Scotland, and the Oban distillery is probably the closest one to me, and it's a very nice distillery. The prod ready ones, as I said, I use cloud. If you are using Kubernetes and you're a company and you're thinking, I want to get started, first up, I'd say, do you really need Kubernetes? It is quite complicated. If you just want to run containers in a cloud that are managed container services, I would start there personally because they're a lot simpler. If you do want to use Kubernetes and it's in an organization and you don't have a huge amount of resources to delve into the security, I would recommend the managed Kubernetes offerings. So that's EKS from Amazon, GKE from Google, AKS from Azure, or whatever else your cloud service provides. Almost all cloud services have a managed Kubernetes. So why do you have multiple folders with layers.tar, as we've been asked? So when we unzipped that container image, why were there multiple folders? The idea is that's one per layer. So Docker uses this idea of a union file system, where each line of your Docker file, if you've ever written a Docker file, you'll see as many lines, gets turned into a layer. And then it puts together the layers together and it unions them all together. So it gets all the layers, squashes them up, and shows you the result. And that's just, it's how it saves space. Because the idea is if I have, say, 100 containers and they all share the same base layer, that means I only have to have one copy of that base layer on my host, which could save you a lot of disk space. So it's basically a disk space saving mechanism, the way that they basically turn every line in a Docker file into a separate layer. And when we unzip the original container, that's what we were seeing, all the different layers in the container image. Hey, Terry says, copy on right. So that's a good question from Daniel about the VPS providers. It's one I really, if I had like more time, I would delve into. Kubernetes security is pretty complicated. There have been a set of CVEs that is ever growing, and on several of the CVEs, there is no patch. The cluster operator has to mitigate. The big boys, Amazon, Google, they're all on top of it, right? I would be surprised to get something interesting there. There are a lot of other ones who, if they're not maintaining their like knowledge of Kubernetes security well, I wouldn't be surprised if you could get something. If it was me, I would be looking for SSRF. So in the managed Kubernetes, the cluster owner is not meant to have access to the control plane. Those control plane nodes are managed by the cloud. SSRF from those is therefore potentially a breach into the cloud provider's network. I wouldn't be surprised to find SSRF vulnerabilities in smaller providers who perhaps haven't got the knowledge to really harden that down. And there are several areas of Kubernetes that provide SSRF-like opportunities. Is there a tool to union the layers into something like the save file? Yeah, typically to union the layers, I'll just use Docker export. If you want to like explore an image, you can use a tool called Dive from a guy called W.A. Goodman. I remember the GitHub is W.A. Goodman. If you look for Dive container images, you'll find the tool called Dive, and that lets you explore images quite nicely. If I remove namespaces from containers, would I be able to interact with one from another? Yes, absolutely. It's a fun thing, actually, because in Kubernetes, you can have multiple containers running in a single pod. And what they do is they share a network namespace. So the idea is that if I've got two different containers in the same pod, they can each see the local host traffic for the other container. You can also share PID namespaces in Kubernetes so that your different containers in a pod can see each other's processes, but that's not turned on by default. There is a switch, however, when you start a pod up, you can say, hey, I want all the containers here to share a PID namespace. So yeah, absolutely. And it's a fun area to play with. You can like create, if you're creating CTFs, you can do some fun stuff with like weird combinations of capabilities and secob and namespaces, which could create things that look like Linux, but act in a weirdly different way. So yeah, absolutely. In general, actually, I'll just kind of finish off. This is kind of an interesting area, and there's some good fun vulnerabilities coming along because you've got this interaction. I actually had a slide for this. You've got this interaction of all these different areas to look for vulnerabilities. You have the Linux kernel. So for example, there's a CVE that came out last week that allows you to do container breakout in Kubernetes, but not in Docker from an unprivileged container, which is a weird thing to do with how the layers hang together. You then have a thing called runC, which is an open source project run by one group, Containerd, which is another open source project, Docker, which manages those two, the kubelet and Kubernetes and container registries. And all of these things have to work together for it to be secure. So there's lots of fun places to poke at. Some Linux kernels, like local privilege escalations, will work. They will give you container breakout, but not all of them. So there's been some bugs in runC, race conditions quite a lot of the time, that when it's creating the container process, there's like a race condition in how it's setting the resources up, and you can get stuff there. And there's been a similar set of race conditions in the kubelet as well. But in general, because there's all these different pieces that work together, there's like places you can try and poke and find out like a bad interaction or an assumption that you know one level assumes that another level works one way and it doesn't. So in general, it's I think kind of a fun area for playing around and looking for problems. Oh, and actually, I have one more thing I was going to mention, if I got time, which I think I do, because no one's telling me to stop yet. There are some fun bugs you can look at, CVEs, that I think are interesting to examine. This one came out last week. This is the one I mentioned in the Linux kernel. The interesting thing here was that this allowed for, there was some, it was CTF players that found this. Actually, it was interesting. There was a bug collision between some people in the UK, who I read their stuff, and Star Labs in Singapore. They found the same bug. But this actually can be used for container breakout in Kubernetes. It only worked in Kubernetes because Kubernetes disables that seccomp filter. So I mentioned, I talked about the layers. The outside layer is seccomp, which Docker has, but Kubernetes doesn't. And so this privilege escalation works in Kubernetes, but doesn't work in Docker. So that was kind of a fun one. There was this one, which was, this is a bug in how containers mount file systems. And this essentially, this was a race condition when you were mounting a volume, and it could give you essentially host namespace access. So that was a fun one. Docker has had some vulnerabilities in how it uses copy. So it's got a command called docker cp, which copies files in and out of containers. And it's using tar under the covers. And there's been fun bugs with how it uses tar, and the fact that if you put a symlink and then you copy something out, it could overwrite files on the host. Because it's using Linux functionality in a weird way, there's been some fun CVEs. The kubelet had, weirdly, almost exactly the same bug as this runc one. So this was the same bug, but in two different layers of the same system, which was a race condition in volume mounting. And they found this one actually after having dug around in what was happening here. They found another one and said, hey, what's going on? And realized it's a bug in the kubelet. So this is what I was saying about there's lots of different layers. And because each layer is setting things up potentially differently, there's scope for CVEs to creep in. And then this one is really fun as well, if you want to read up on it. This bug allowed you to send localhost traffic to a Kubernetes cluster from another machine in the same network. So you could send traffic to 127.0.0.1 on a Kubernetes cluster node. And the reason for that is Kubernetes set one of the flags in Linux that allows you to do that, which is a really weird flag, right? Localhost is localhost. You can't send traffic remotely. Yes, you can if you turn this particular flag on in Linux. And Kubernetes turns that flag on. Their fix for it is to add an IP tables rule to block stuff. So yeah, that was a fun bug. But reading all of these bugs can be quite interesting if you really want to know what's going on, because when you understand, when you read the bug and go, how did that work? Then you go, oh, this is because it's doing this particular thing. So there's lots of different fun vulnerabilities to play with in there. Oh, any other questions, or are we good? Knowing Terry, it's going to be more whiskey questions if he asks.
All right, any more questions? Okay, if not, then, well, thanks, Rory. Now we know how awesome Docker